Hello. Excuse me. Hello. I will review homework 2, question 1. And by the way, before starting this, I apologize that the homework 2 is really difficult. Algebraically, it's very complicated, but that's because it is an important chapter. Endogeneity is the most important idea to any applied economist. So, as I said, as I repeat several times, finding a good IV is what you're going to do in your dissertation, right? So, um, so like take this seriously. You have to be familiar with the idea of endogeneity and what is going on, how you can handle that. Okay. So maybe homework 2 must be the most difficult homework in this course. So you have passed passed the most difficult part is behind you. Okay, good for you. But still, many of you have done pretty good job in question 1. So, and I will post this answer key, and if you wonder a different way to solve your question, then you can look at my answer, but not much different. Excuse me. Um, so, what I wanted to say here is, let me tell you a few things. So in some of the questions, I usually say, the questions are usually like find conditions under which something happens, something is satisfied. So that's what you're going to do in your research. You have to find the conditions to do what you want to do, right? So, and in this case, theoretically, you have to express the conditions in terms of underlying exogenous variables and parameters, right? So, for example, in this question, the true models are given by these two equations: the true equation and how observed variable h is generated. These are the underlying true equations. But the third equation is just for your use. It does not exist. This is just what you imagine, and you don't know if it's correct or not. So it is not the truth. So all the objects in this here, so for example, epsilon tilde means nothing. So it is just arbitrary residual, based on your approach. So you don't know what this is, and so when you analyze what you're doing, you have to utilize these two equations. And then, somehow I did not complete the answer. I will. And another thing, then that means, for example, let me show you some example. Some of you have considered, for example, in part B, in question B, I asked you to calculate the misspecification bias. So for example, in this answer, the answer bias includes covariance between h and epsilon tilde. This is not desirable because first, epsilon tilde it does not exist. It is just your definition, and it is not true, not a part of the true equations. And h is also h can be broken down into two underlying variables. So what is more desirable is replace here in this condition, replace h here, replace h with k plus u. And also because the independence assumptions are imposed on k and u. So all the conditions are not on h, but on k and u underlying variables. Similarly, epsilon tilde should be replaced by the underlying disturbance terms. So that's how we approach, how we discuss in theory. So in theory, you have to understand what is the most fundamental underlying variables, and that's the basis of your analysis, right? And 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 anything more to say about that? Maybe not. And some algebraic details. So I use expectation x times y as if covariance x comma y, but for this equality, you need this condition, right? You cannot abuse this equality everywhere. You have to make or at least assume the mean equals to 0 for one of them. Similarly, when I even if I say expectation x squared equals variance, but also it requires mean of x is 0. So otherwise, you cannot switch between them. So keep that in mind. And furthermore, I think I did it. I mentioned it in homework 1 and in class. This holds only when the regression has one intercept and one regressor, one variable. So this is not a general formula. So at the PH level, you cannot use this in general. So this is not general enough. And one more thing is, it is nice to calculate 3x3 matrices determinant, but usually we don't do this. So I appreciate the effort, but I don't recommend this. It's literally waste of your time. So if you need to do this, think about a better way. So at least in my course, I'm not going to ask you to do 3x3 matrix, but at most 2x2 is the maximum. So what you have to do here is just demean all the variables. This is the technique I introduced at the beginning of the course. So because this is useful, it will save a lot of work. So after demeaning all variables, you can remove the intercept. So then remove the intercept and just replace everything with tilde variables. And then it is 2x2 algebra, which is much doable, which is much easier. Still annoying, but it's possible, right? And then here I continue the work like this. And that's it. One more thing. So in this question, what one key problem is that, let me see, the weak instrument approach. So your answers are mostly correct, and there is a kind of critical error in the question. That is, in class, I explained as if the weak instrument means this thing. The covariance between the instrument and the endogenous variable goes to 0. Or their matrix determinant converges to 0. But in this example, actually this is not exactly the case because first, because there are 2x2 case, so you have to think about 2x2 matrix. Not this one. So you have to think about this determinant close to 0. That's the first thing. So when there is only one endogenous variable, one instrument, this is covariance. But in general, 2x2 case, you have to think about determinant close to 0. And another thing, what's more important here is, in this case, even if you ignore the other variable and just assume there is only one endogenous variable, so covariance goes to 0 causes another problem, because when the covariance goes to 0, at the same time, it means either it's relative thing. So the variance of the instrument will change together, right? The variance of the instrument will change as the covariance goes to 0, right? So that is not the standard case. In theory, in my lecture note and in most textbooks, they assume that usually we fix the variance of the instrument and consider covariance goes to 0. But in our case, they are linked together. So you cannot send covariance to 0 without affecting variance. To do that, so a better approach, theoretically better approach, is to fix the variance of the instrument, and instead we consider the variance, the ratio changes. So the variance of the instrument depends on the two things. So h is coming from k and u. So some of these two variances are fixed. Suppose that some of these two variances are fixed, but their relative ratio can change. And then, obviously, as the variance of u increases, the covariance between h and g will decrease, right? So k is the covariance. K takes care of the covariance between h and g. So as the variation in k increases, the covariance between endogenous variable and instrument will increase, and vice versa. If it decreases, then covariance decreases. So it's my fault. I did not explain this well in this question. So a better presentation of this theory is based on this ratio, right? In the sense that we control for the variance of instrument and changing the covariance to study the weak IV, right? And this is particularly, and I just wanted to say that this is the signal to noise ratio in information theory, but I was too ambitious to do that. Okay. Okay. I will do question 2 in another video, in the next video. See you later.